Welcome back, site carpenters of Genesis International College. Let's jump right into this explainer. Today, we're going to be exploring how to master the final and honestly, the most critical safety phase of your external timber stairs project, which is fitting handrails, balustrades, and all those finishing touches. Think of this as your ultimate summary guide. We've drawn this directly from topic 4 of your course materials so that when you step onto that job site, your work is perfectly compliant and structurally rock solid. Here is our roadmap for today. We're going to cover 1. The ultimate safety barrier. 2. Strict rules for balusters. 3. Cutting and trial fitting. 4. Securing the handrails. And 5. Final checks and cleanup. Okay, so before we even touch a single piece of timber, we need to get our mindset right. We are not just fitting pieces of wood together today, we're engineering a life-saving safety barrier. I absolutely love this quote from your course material because it really grounds everything we do. It says, by keeping the gap small and the structure stiff, you provide a protective barrier that meets the legal safety standards for residential building projects. And at the end of the day, that is your ultimate goal as a professional carpenter. Let's start with Section 1, the ultimate safety barrier. To do our jobs right, we've got to start with a clear definition. What exactly is a balustrade? Well, it's the infill between the handrail and the stringer, or the floor. It acts as the primary barrier to prevent children or, objects from falling through the side of the stairs. Understanding this is absolutely vital because every technical specification we follow, every cut we make, and every single screw we drive is specifically designed to uphold this exact safety function. Moving right along to Section 2, strict rules for balusters. Building compliance basically comes down to 4 easy-to-remember pillars. First up, vertical orientation. Balusters have to be placed vertically so kids can't easily climb them like a ladder. Second, strict spacing. Third, structural rigidity, meaning every piece is securely fixed at both the top and bottom to prevent any twisting or rattling. And fourth, specific height requirements. Let's zoom in on that spacing rule for a second. The absolute crucial point here is the 125mm rule. The gap between your vertical balusters must be small enough that a 125mm sphere cannot pass through it at any point, period. Now, you might be wondering, why such a highly specific number? Well, to put it into a real-world perspective, 125mm is roughly the size of a small child's head, which is exactly why this metric is strictly enforced by the National Construction Code. If that gap is even a little bit larger, a child could slip through. So precision in your measuring and marking phase isn't just a best practice, it's a legal requirement. Let's see how this ties into our height requirements. Basically, if a potential fall to the ground from a landing or a deck is more than 1 meter, the entire balustrade has got to be at least 1,000mm high. This ensures the barrier safely supports, say, an adult who happens to lean against it. All right, Section 3, cutting and trial fitting. Look, cutting handrails definitely requires a bit more finesse than rough structural framing. Because users are going to be running their hands along these surfaces, you really want to prevent breakout and splinters, so follow this sequence. Step 1. Equip a 60 to 80 fine-tooth finish blade on your compound miter saw. Step 2. Adjust your miter saw angle carefully using your sliding bevel. Step 3. Clamp a stop lock to your saw station. This is a fantastic trick for making identical, super fast cuts for your balusters. And finally, Step 4. Always let that saw motor reach full speed before letting the blade touch the wood. But hold on, before you grab your drill and start applying any permanent fixings, you have a critical intermediate step, trial fitting. This is your essential safety check. We all know the rule. Measure twice, cut once. Place your handrail between the newel posts just to verify the joints are tight. Stretch a string line to check for bowing. Doing this trial fit allows you to verify that joints are perfect and your spacing aligns exactly, which cuts down on material waste and guarantees a solid structure. On to Section 4, securing the handrails. So once your components are perfectly cut and tested, it's time to lock them in place. This workflow maps out exactly how to secure the rail to create a really rigid connection. First, offering it up, meaning you place the cut section in to check your miters and butt joints. Second, verify that 865 to 1,000mm height above the pitch line. Third, check the level, plumb, and line with a spirit level and a string line. Fourth, always pre-drill your holes. This stops the timber from splitting before you drive your fasteners. And finally, clean the joint to wipe away any excess construction adhesive. Now, a quick but crucial note on hardware. When you're pre-drilling and fixing, your hardware choice really matters. You can't just grab whatever screws are rolling around in your pouch. Always match stainless steel screws to hardwood timbers, and make sure you use hot-dipped galvanized screws for treated pine. If you mix these up, you risk this really ugly rust staining bleeding down your timber over time, and that completely ruins the professional finish of the staircase. Finally, Section 5, Final Checks and Cleaner. To finish the job like a true professional, you must systematically run through your quality assurance checks. Do a plumb check by throwing a spirit level on every third baluster to ensure they are perfectly vertical. Aggressively test the stability with some firm hand pressure. There should be absolutely no rattling or play. Do a safety gap verification to ensure gaps never ever exceed 125 millimeters, particularly near the posts. Check your structural fixings at the top and bottom. And lastly, run your hand over all the surfaces to ensure every screw is countersunk and there are no snag hazards at all. Building external stairs. It's a massive responsibility. But by following these exact steps from Genesis International College, you'll be building barriers that are not only beautiful, but incredibly strong. So as you head out to the site to assemble your next project, ask yourself this. If a 125 millimeter sphere were to test your staircase today, would it pass? Are your measurements precise enough to protect a life? Keep that high standard in mind, and you will always deliver outstanding work. Thanks for learning with me on this explainer, and I'll see you next time.